Hello and very welcome everyone to this session of the World Geography Part 1. In today's session, we are going to start this chapter of geography in which we are going to discuss the relevant things that would be helpful in the upcoming exams. So let's start. Before we start, the images, text, and other materials used in our presentations are for educational purpose only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the same. So let's read some important definitions first and then we will try to understand that what exactly is world geography. So cosmic, the term is related to the universe or cosmos. So cosmic is a term that is associated with the universe, and cosmos or universe is the thing in which we learn about the cosmic waves. Apart from that, cosmology is also known as the study of universe. Cosmos is another name of the universe. So universe is the collection of all these galaxies that we see around our Earth. Like our Milky Way, there are billions of galaxies in the universe. So that is the total universe, and it is also known as cosmos. Cosmic rays. So cosmic rays are very powerful atomic nuclei or other particles that move through space nearly at the speed of light. Their speeds vary depending on their origin and interactions with magnetic fields. They originate from the Sun, from outside of the solar system in our own galaxy, and from distant galaxies. It causes cancer. Cosmology, the scientific study of the large-scale properties of the universe as a whole. So, as I told you earlier also, that study of universe is known as cosmology. Cosmological, it is related to the origin and growth of the universe. Astronomy. Astronomy is the deep scientific study of celestial objects such as stars, planets, comets, etc., and everything that originates outside the Earth's atmosphere, like gravitational waves, solar winds, etc. So, we have learned about what is cosmos, cosmic rays. Cosmic rays are the atomic nuclei waves, and they travel through space at the speed of light, and depending on their origin and interaction with the magnetic fields, their speed vary. And they originate from the sun, from outside of the solar system in our galaxy, and from distant galaxies as well. And apart from that, astronomy we learned about is the study of the celestial objects such as star, planets, comets, etc., and that originates outside the Earth's atmosphere like gravitational waves, solar winds, etc. There are three most famous theories related to the origination of universe. So whenever we learn about this thing, origin of universe, we know that the most accepted theory right now is the Big Bang theory. But let's learn about other theories as well. So first is the steady state theory, then the pulsating or oscillating universe theory, then the Big Bang theory. So these are the three theories in the universe, in the origin of universe. So steady state theory, it was given by Hermann Bondi, Fred Hoyle, and Thomas Gould. According to this theory, the universe has neither a beginning nor an end, in which an old galaxy shifts apart and new galaxies are formed in the vacant region. Pulsating or oscillating universe theory. Pulsating universe theory is said that the universe expands and contracts alternately, that is, it pulsates. The universe is expanding at present. It is explained by the phenomena of the redshift. The collapse of matter is called the Big Crunch. And this is the pulsating theory. Under pulsating theory, it is said that the universe is expanding and then contracts like a heart. And right now it is in the position of being expanding. And The time when it starts collapsing, it is called the Big Crunch. And another theory that we learned about is the steady state theory. And in this theory, the universe has neither a beginning nor the end, in which an old galaxy shifts apart and new galaxies are formed. So basically, it is just saying that it is a continuous process. It has no beginning, no end, and it will be going on. The old galaxies will go away and the new galaxies will form. So that is the steady state theory, and that was given by Hermann Bondi, Fred Hoyle, and Thomas Gold. Then came the most accepted theory so far, that is the Big Bang theory. So a big explosion occurred about 13.8 billion years ago. Due to this high intensity explosion, the matter was broken into very small pieces which scattered in all directions with very high velocities and formed stars and galaxies. At present time, they are still moving away from one another. And this theory was given by George Lemaitre. The galaxies are receding away from each other. It is proven by the shift of the spectrum towards the red end. The majority of atoms produced by the Big Bang were hydrogen and helium, along with trace amounts of lithium and beryllium. So these are the elements that we found when the universe expands, and these are the atoms that are formed out of it, and because of which the Big Bang theory is the most accepted one. And as soon as the Big Bang happened, the three things came out of the point of singularity, that were time, space, and matter. And do remember, this theory was given by George Lemaitre. The collection of the huge mass of stars, nebula, and interstellar material is known as galaxy. So now we are learning about the galaxies. So galaxies are the collection of stars, nebula, and interstellar material. About 1 lakh stars are present in the smallest galaxies, which while the largest one contains up to 3000 billion stars. So that is the difference between the smallest and the largest one. So far what we have discovered is that we have approximately 10 to the power 11 galaxies in our universe, and out of them, if the smallest one has the 1 lakh stars, up to 1 lakh stars, and the largest galaxies have up to 3000 billion stars. There are three types of galaxies basically. So spiral galaxies contain spiral arms of interstellar matter and are flattened disks. In the center of the spiral galaxy, there is a great concentration of stars. Example, the Andromeda Galaxy and Milky Way Galaxy. Milky Way Galaxy is our galaxy in which our solar system exists, our sun, our earth exists, and Andromeda is the closest galaxy to our galaxy, that is the Milky Way. Then elliptical galaxy. These type of galaxies have a symmetrical elliptical or spheroidal shape with no clearly defined internal structures. It contains a big number of old red stars and has very little raw material for the formation of new stars. Approximately 15 to 20% of galaxies of our universe are elliptical, and that is why I said earlier also that galaxies consist of approximately 10 to the power 11 galaxies are there in universe, and these are of different shapes and size. Then comes the irregular galaxy. These type of galaxies do not have a common axis, so they don't spin regularly. Irregular galaxies are occupied with gases and layers of dust, and they are comparatively lighter ones. The Milky Way Galaxy. It is a medium-sized spiral galaxy. It contains 100 billion stars, and its diameter is 1 lakh light years, and thickness is 10,000 light years from the center. The Milky Way Galaxy has the shape of a flat disk with a central bulge. From the galactic center, our solar system is 227,000 light years away. And at the center, you will always find, in every galaxy, at the center, you will always find a black hole. In the Milky Way, the central point at which the black hole exists is called the Sagittarius A. That is the point where the around which our Milky Way galaxy has been formed. The Sun completes one lap of the galaxy in about every 230 million years and is about two-thirds out from the center. The solar system is located in the Orion Arm, 27,000 light years from the center, about one-third from the center of the Milky Way galaxy. So these are the datas that we need to understand, and 1 light year is equal to 9.46 into 10 raised to the power 12 kilometer. So you can understand that what exactly numbers they are saying when they are saying 1 lakh light year or 10,000 light years. I hope now you are able to understand all of them. Now facts about the Andromeda galaxy. The Andromeda galaxy is the biggest among the local group of galaxies. Andromeda is also bigger than our galaxy Milky Way. This galaxy is 10 billion times more luminous than our Sun. Light from Andromeda takes 2.5 million years to reach the Earth. That means they are this far away that the light from the Andromeda will take up to 2.5 million years to reach the Earth. So that is the distance between the Andromeda and the Milky Way. And if we talk about the distance in the space, they are measured in three different type of units. One is the light year that is generally used. The largest one is the parsec that is equal to 3.26 light year. And one is also called the astronomical unit, and it is defined with the distance of Earth and Sun, that is 150 million kilometer. So that is called astronomical unit. So these are the three different type of distance units that are used in space. So let's talk something about stars. So stars are born in nebula, and they are bodies of hot glowing gas. Its surface temperature ranges from about 3000 degrees Celsius to 50,000 degrees Celsius. Like our Sun, surface temperature of Sun is around 6000 degrees Celsius. Stars contain some gases, and they are hydrogen, that is 92.1%, helium 7.8%, and other gases 0.1%. Proxima Centauri is the nearest star to the Earth. Even when light comes from there, it takes 4.24 light years to reach us. There is a nuclear fusion of hydrogen into helium in the star's core. Due to this reaction, a huge amount of energy is released from the stars become shining. So Proxima Centauri is the second nearest star from Earth after the Sun, and the third nearest is the Alpha Centauri. Now let's talk about the star life cycle, that is the birth of a star. So the cradle of stars are nebula because they have the same chemical composition as that of stars, mostly hydrogen and helium. The gravitational contraction from vast clouds of galactic gas and dust are the main reason behind star formation. Then protostars. A protostar looks like a star, but its core is not yet hot enough for nuclear fusion to take place. Nuclear fusion, the fusion of two hydrogen atoms into a helium atom with a liberation of a huge amount of energy. Nuclear fusion occurs only when the initial temperatures are very high, a few million degrees Celsius. That is why it is hard to achieve and control. So basically, the nuclear fusion process is a very tough process to gather because as it requires a high temperature to achieve, and that is very difficult to achieve and control as well. And that is why the difference that we can see between the nuclear fusion and nuclear fission is that stars generate energy with the help of nuclear fusion, but the atomic bomb and hydrogen bomb, the atomic bomb that are found on the Earth are made of the process of nuclear fission, whereas hydrogen bomb is made of the process of nuclear fusion. So that is the difference between them. And our nuclear reactors also work on the basis of nuclear fission. But recently China has created an artificial sun that is basically a nuclear reactor that works on the nuclear fusion process. So that was recently developed by China. The red giant. Red giants have diameter between 100 to 1000 times that of Sun. They are very bright, although their surface temperature is lower than that of the Sun. A red giant is formed during the later stages of the evolution as it runs out of hydrogen fuel as at its center. White dwarf. A white dwarf is a very small hot star, the last stage in the life cycle of a star like the Sun. White dwarfs are the remains of normal stars whose nuclear energy supplies have been used up. White dwarfs consist of degenerate matter with a very high density due to gravitational effects. That is, one spoonful has a mass of several tons. Black dwarf. The last stage of stellar evolution is a black dwarf. A black dwarf is a white dwarf that has sufficiently cooled that it no longer emits significant heat or light. Then massive stars. These stars have an extremely high amount of energy and they have a mass at least 3 times that of a sun. After passing through the main sequence stage, a massive star becomes a red supergiant. It contracts to become a black hole when the core is greater than 3 solar masses. So basically, a star, as soon as it is born, it defines the future of that star. Especially the mass of that star defines the future of that star. If the mass is less than Chandrasekhar limit, as Chandrasekhar was a scientist in India who discovered this limit, that is famously known as Chandrasekhar limit. If the star has the mass that is less than Chandrasekhar limit, then the future of that star will be a white dwarf and black dwarf. But if the star has a mass equivalent or greater than the Chandrasekhar limit, then the future of that star will be either a black hole or a neutron star. And that's it in this session. I hope you learned a lot of things with me in this session of solar system universe. I will meet you in the next session. Till then, bye bye and thank you.